Okay, Gravity Lab Part 2. So what we discovered in Part 1, or what was explained in Part 1, is that we're pretty bad at timing things, especially when they happen over very short time periods. And this was very apparent to some old scientists. So imagine that you're way back in the 1600s, and maybe you've heard of a guy named Galileo way back in the 1600s. Recognize this. It was just really hard to time things, especially back before we had video cameras or watches or phones. Just imagine that for a second. And yet he thought that humans were a lot more accurate at measuring distance. So he actually made these ramps. It'd remind you a lot of Hot Wheels ramps that he rolled bowling balls down. These ramps were like miles long, over a mile long, some of his longer ramps. And then he was able to more accurately gauge the time over that longer distance. The calculations became a little bit easier. And actually, way back in the 1600s, Galileo came to the correct, if not exactly accurate. And what I mean by that is he's off by like 0.01 meters per second. And he came to 9.8 meters per second for the acceleration due to gravity by making these long ramps, accounting for friction, making as low of friction as he could, just running thousands and thousands of experiments. We don't have time to be Galileo, but we have time to maybe imitate him. So today, in Part 2, we're going to use ramps. We're going to use paper ramps to extend the time it takes to fall that same distance. When you fall an angle, it's extending that time that it takes to cover that same distance downwards. Basically, geometry, if you ever heard of sine and cosine. I'm trying to remember which one we use here. I forget if that's sine or cosine, actually, off the top of my head. It's been a while since I've done that as well. But it is the right equation. Once again, don't get bogged down in the equations today. There is a calculator for you. It's the second tab in our gravity calculator Google Sheet. Sorry, saying the right thing. And basically, you're doing the same experiment, except this time you're just rolling your object down a ramp instead of dropping it straight down. Let me show you what that would look like in class. In class, you'd make some sort of a ramp. I kind of cheated and made one big ramp. I have some bigger poster paper. You might tape smaller pieces of paper together, and then you just measure the length of that ramp. Now, once again, ramps aren't perfect, especially if they're made out of paper. You are going to have a little bit of bend, a little bit of give, loss of momentum due to friction, stuff like that. But usually, typically, we get much closer. Typically, the first set of data is very, very far away from gravity. And then this one, we get closer. Still probably not quite there, but it does kind of start to get closer. And then I think the point is proven. So all you do is take your object. I used the tennis ball last time, so I use it this time. Start at the top, roll it down, and measure the time it takes to get to the bottom once again. So you're measuring the time from the top to the bottom. Then you'd measure the height of your ramp. So the height up to here. And the length of your ramp, the length out to there. And then there's an equation that you can run it through. It's given in the doc, but you can just use your calculator here to enter your data. So let's see here. There's my gravity calculator. Sorry, I was on the wrong tab. And in tab 2, you just enter in your data, your height, your length of the ramp, and then your average time down the ramp, and the height length conversion and acceleration due to gravity will do themselves. This time you do not need the mass. We didn't do the force in this one. Just trying to prove that we can get closer to gravity by using this method. So there you go. There's part 2. Once again, if you're at home, stuck at home, not able to do these accurate measurements, or don't want to, I guess, because this one you probably could do if you really wanted to, then I do have the previous year class data available to you. If you don't want to do that, or you're in class and you get your own data, you can use the part of the data table below the gray line. Go back and finish your reflection questions. You still need to do the reflection questions, and then you are done with the lab. Thank you very much. Have a good day.